multiple regression problem is solved using matrix math. This video will be a short introduction to matrix math as it is performed by Excel. First of all, what is a matrix? Let's look at this set of numbers. If we think of these numbers as a set, we could call these numbers a matrix. Excel calls the numbers an array, but is a little bit schizophrenic about the use of the term array because it also refers to functions that work with these arrays as matrix functions. If we have this matrix or this array, which we will call X, one of the functions that we can perform with Excel is to find the transpose of this matrix. There are two ways we can get the transpose, and I will designate the transpose as X prime. And incidentally, matrix designations are always capital Roman letters, and they are given in boldface. So there are two ways I can find the transpose of this matrix in Excel. One is to copy the matrix and paste special transpose. And now we have transposed the matrix. By transposing the matrix, what has happened is that this column becomes this row, and this column becomes this row. There's a second way that we can transpose the matrix. I'll clear the contents, and when I look at this matrix, I see that it has 4 rows and 2 columns. So the transpose has got to have 2 rows and 4 columns. Once I have highlighted the 2 rows and 4 columns, I can use the function equal transpose. And if I select the original matrix and hold down Control Shift and hit Enter, I get the transpose of the matrix. An interesting thing about this transpose is that it's live in the sense that if I change this 2 to 4, for example, it's changed to 4 here. I'll go back to the 2. Now we have what is called a 4 by 2 matrix and a 2 by 4 matrix. Matrices are always given as rows first, columns second. We can also multiply matrices together if they conform for multiplication. This matrix is 4 by 2. This matrix is 2 by 4. If we multiply this matrix times this matrix, we're multiplying a 4 by 2 matrix times a 2 by 4 matrix, and because the columns in this matrix match the rows in this matrix, we can multiply them together. So let's see what we get if we multiply X times X prime. First of all, if we're multiplying a 4 by 2 times a 2 by 4, we will get, as a result, the outside values, that is, rows and columns. So the resulting matrix will be 4 by 4. If I now use the function equal mmult, which means multiply matrices, I can take the first matrix, then a comma, and the second matrix. And when I hold down Control and Shift and hit Enter, this is the result of matrix multiplication for x prime. There's also another and more important matrix multiplication for multiple regression, which is multiplication of x prime x. If we multiply x prime x, we're multiplying a 2 by 4 times a 4 by 2. The result of that will be 2 by 2. So here is x prime x. It is equal to m mult. Select the first matrix, that is x prime, and then select x, hold down Control and Shift and hit Enter, and we get these values. Matrices may also have inverses. An inverse is typically designated x prime x to the minus 1. It's actually x prime x raised to the power of minus 1, but we will just show minus 1. Now to get the inverse of this matrix, we will use the function equal m inverse, that is matrix inverse. Select the x prime x matrix, hold down Control and Shift and hit Enter. And this is the inverse of the x prime x matrix. What is the value of the inverse? Well, if we multiply x prime x times x prime x inverse, we get essentially unity. If we were working only with scalars, if we took the value 54 and multiplied it times 1 divided by 54, the result would be 1. That is the nature of an inverse. With matrices, the result is somewhat different, but let's put the result here. This is going to be x prime x times x prime x minus 1. And I'm going to find that again using equal m mult. So there is x prime x, a comma, x prime x inverse, Control Shift Enter, and I have 1s on the main diagonal and 0s in the off diagonal elements. This is essentially the unity matrix. The value of this inverse is that I can multiply other matrices by this inverse, and it's essentially equivalent to dividing by this matrix. Let's look at another matrix, which we're going to put right here, and we're going to call it y. And we're going to call it y with a small letter because it's going to be a matrix that is 4 rows but only 1 column. And let's say it looks like this. Now, I can also multiply x prime times y, and I'll do that right here. Because y is 1 column, x prime times y is going to be 2, that is 2 rows, times 1 column. So it will just be these two positions. So again, I'm going to use equal m mult. I'm going to select x prime, comma, and then I'm going to select y. Hold down Control Shift and hit enter, and I have now calculated x prime y using matrix multiplication. Now what I have here is this as one equation and this as another equation, and there are coefficients which, when I multiply them, the coefficient times 54 plus the second coefficient times 34, I will get 62. And again, if I multiply the same coefficient times 34 plus the same coefficient times 30, I will get 50. How do I find those coefficients? Basically, to find those, I will multiply x prime x inverse times x prime y. And I will do that right here. Because x prime x inverse is 2 rows and 2 columns, and x prime y is 2 rows and 1 column, the result will be 2 rows and 1 column. And I will say equal m mult x prime x inverse, comma, x prime y, Control Shift Enter, and these are the two coefficients that multiplied times these values will produce these values. Let's look at what I'm saying. If I say that 54 times 0.34 plus 34 times 1.27, I will get the result 62. I can also do the same, equal 34 times 0.34 plus 30 times 1.27 equals 50. But essentially what I've done is matrix math. I've multiplied this matrix times this matrix and produced this matrix. Let's do it again one time over here with m mult, equal m mult, select x prime x, comma, select the coefficients, Control Shift Enter, and I have 62 and 50. This is a very short introduction to matrix math and the Excel matrix functions.